Hey everyone, for my interactive case study 4, I'm going to be taking you through one of the most amazing medical discoveries, penicillin. Today we'll examine how it works, how bacteria has developed defenses against it, and also the implications to our society today because of it. As you'll see later in my presentation, I also utilize the UCSF chimera to view penicillin coupled to its target enzymes. Let's get started. Now let's start on my first slide titled, What is penicillin? When Alexander Fleming spotted mold-killing bacteria in a petri dish in 1928, he realized that penicillin was the first real antibiotic. The B-lactam ring, which targets bacterial enzymes that form the cell wall, is what gives it its strength. By imitating the D-ala-D-ala structure that bacteria naturally use, the ring prevents them from forming robust cell walls, which eventually leads to their defense. Numerous lives were saved and medicine was revolutionized because of this discovery by Alexander Fleming. Now on to my next slide, titled The Bacterial Cell Wall. Peptidoglycan, a robust mesh-like layer composed of short peptide chains and repeated sugar units, makes up the bacterial cell wall. Under pressure, this structure keeps the cell from exploding. These peptide chains are joined by the enzyme transpeptidase, which penicillin inhibits. This prevents the wall from forming correctly, weakening the bacteria and ultimately causing them to rupture. Now onto my next slide titled Mechanism of Action. Penicillin functions similarly to the molecular imposter. It fits into the enzyme transpeptidase active site, which connects the bacterial cell wall. The enzyme is irreversibly blocked when the B-lactam ring combines with the serine residue. The bacteria finally die because the wall cannot remain intact in the absence of transpeptidase. Now onto my chimera visualization slide by UCSF Images. So the images to the right are my chimera visualizations from the PDB structure 2J8Y, which brings me to my slide. The intricate 3D folding composed of the A helices and B sheets are visible in this. The B-lactam ring of penicillin is positioned precisely where the catalysis would take place at the enzyme's active site, as shown in my close-up image down below. This demonstrates unequivocally how penicillin inhibits the enzyme via acylation, therefore validating its inhibitory mechanism. Now I'll go on to my following slide. How does bacteria do this? Microbes are cunning. They have evolved a number of defenses against B-lactam antibiotics throughout time. Some create lactamase enzymes that break apart the B-lactam ring and destroy the medication, while others restrict drug entrance by decreasing cell permeability. To make penicillin ineffective, some strains even change their PBPs, plasmids, which are the little DNA rings that bacteria exchange like survival secrets. And these are often the resistance characteristics that proliferate. Finally, for my last slide of my presentation, it is titled Antibiotic Resistance. Penicillin transformed medicine by almost instantly making fatal illnesses curable. However, the cost of its extensive usage was the rise of antibiotic resistance worldwide. The map on the right of my PowerPoint slide illustrates the current regional variations in resistance rates, with portions of Asia and Africa showing the greatest levels. While maintaining the fundamental function of penicillin, scientists are trying to alter B-lactams and outsmart resistant bacteria. The development of the next generation of antibiotics that may save lives depend on an understanding of resistance at this molecular level. In conclusion, despite its apparent simplicity, penicillin has a significant influence on human health. It kills microorganisms by stopping the formation of bacterial walls. However, bacteria are always changing, which serves as the constant reminder that science must constantly change also. I really hoped you liked following along with me in my presentation as we explored the molecular history of penicillin. Thank you so much for watching my presentation and have a good day. Thank you.